A sequence diagram is a type of illustration that graphically represents the physical state of each component in a system. Sequencing charts can be used in electrical, fluid, or combined systems. They are used to aid the user in understanding the operation of the system and to help identify which components are actuated or energized at any given time during the system cycle. Many sequence diagrams are used as auxiliary documentation to assist with illustrating the information conveyed on schematics or circuit diagrams. While there is no official standard for drawing a sequence diagram, most are drawn with the time elapsed on the horizontal axis and the action accomplished on the vertical axis. To build a sequence diagram, each major component is assigned a horizontal line. The width of the line shows the time period during the cycle that each component is actuated or energized. It should be noted that this width may not necessarily correlate to a specific time, such as 1 second or 1 minute. Rather, the purpose of the horizontal line is to show each component's state in relation to the other components. The start of a typical cycle is annotated at the left vertical line marked Cycle Start. The action progresses toward the right until the end of a cycle at the vertical line marked Cycle End. Other major milestones may also be denoted by vertical lines. Typically, if an action is instantaneous, it will be noted with its own vertical line at the appropriate point in time. If the milestone is continuous, such as a cylinder extending or retracting, it will be identified by its own horizontal line with arrows indicating the start and end of the milestone. The actual time duration of the cycle in seconds or minutes depends upon the speed at which a cycle is completed. This sequence diagram can be expressed with both a hydraulic schematic and an electrical wiring diagram. To start this cycle, the operator presses the push button. Line 1 on the sequence diagram indicates that the push button may be held down for a variable length of time, as indicated by both solid and dotted lines. When the push button is depressed, the relay coil and the valve solenoid immediately become energized as shown on lines 2 and 3. Now that the relay coil is energized, relay contact 1 CRA closes and also becomes energized as indicated on line 4. This sets up a holding circuit through switch 1 LS and contacts 1 CRA, which keeps current on the relay coil and the valve solenoid even though the push button has been released. Since solenoid A is now energized, the valve shifts accordingly to allow fluid into the blind end of the cylinder. The cylinder travels forward and at the end of its stroke actuates limit switch 1LS on line 5. When the switch contacts open, current is removed from the relay coil. Relay contacts 1 CRA open, removing current from the solenoid valve. Internal springs shift the solenoid valve spool to the cylinder retract position and the cylinder starts its return stroke. Switch 1LS contacts close again as the cylinder backs off the switch, but the relay coil and valve solenoid do not become energized again because contacts 1 CRA are open at this time. This begins again when the operator engages the push button once more.